In section 4.5, we're looking at systems of linear equations and problem solvings. Our objectives are to solve problems that can be modeled by a system of two linear equations and solve problems with cost and revenue functions. The third objective is something that will be covered when you get to college algebra. Here we want to use a system of two linear equations to solve each problem. First thing we should do is read the entire problem, identify the variables, and then translate each sentence into an algebraic equation. One number is 5 less than a second number. Twice the second number is 2 less than 5 times the first. Find the two numbers. So the variables in this problem are the two numbers, which we'll use x and y. So we'll let x be the first number and y be the second number. Looking at the first sentence, we see one number is 5 less than the second number. So one number, we'll say x, is, using the equal sign for is, 5 less than. That means we're going to be taking away 5 from the second number. So one number x is 5 less than a second number y. So x is equal to y minus 5. The second sentence that we'll use to write the second equation is twice the second number. So that's going to be 2 times the second number y is, when we see that is, that's our equal sign, 2 less than. That means we're going to be taking away 2 from the next quantity, which is 5 times the first. 5 times x. So twice the second number, 2y, is equals 2 less than 5 times the first, so 5x minus 2. Now we have a system of linear equations, and in the previous sections we looked at the graphing, substitution, and the addition method, or the elimination method. So we can decide which method to use here. Because our first equation already has one variable solved by itself, this is a good time to use the substitution method. So we're going to take the x that's in the first equation, and we're going to substitute that into the x in the second equation. So our equation is then 2y is equal to 5x, but the x we're going to replace with y minus 5 minus 2. Now we're going to solve this equation by using the distributive property, and we can write the equation as 2y equals 5y minus 25 minus 2, and then we can subtract 5y from both sides, and we get negative 3y is equal to, the negative 25 minus 2 is negative 27, and then we divide by negative 3 to get y is equal to 9. So y is equal to 9, that means the second number is equal to 9. Now we're going to put this answer back into the first equation. Again, that first equation was x equals y minus 5, and we're going to replace the y with 9. So x is equal to 9 minus 5, so x is equal to 4. So our solution to this system of equations is 4, 9, so that the first number is 4, and the second number is 9. Always a good idea to check your solution, and we can do that by looking at each original sentence. One number is 5 less than the second number. Well, 4 is 5 less than 9, so that holds true for the first sentence, which is our check step in the first equation. And then twice the second number, or 2 times 9, which is 18, is 18 2 less than 5 times the first. Well, 5 times the first is 20, so 18 is 2 less than 5 times 4. So it works in the second equation as well. So we know that 4, 9 is a solution to that system of equations. Two trucks leave a city and head in the same direction. After 7 hours, the faster truck is 56 miles ahead of the slower truck. The slower truck has traveled 301 miles. Find the speed of the two trucks. This is a word problem that we can use a system of equations to solve. And whenever I see a problem that has to do with the time, the speed, and distance, then I use the equation that relates all of those concepts, in which we could say that distance is equal to the rate, that's how fast you're traveling, in this case miles per hour, times the time. So distance is equal to rate times time. Since we're dealing with a fast truck and a slower truck, we can make a table of values here and fill in the quantities that we know and use variables for the quantities that we're trying to find. So I'm going to label this first column F for the fast truck and S for the slow truck. And then we're looking at the distance, rate, and time. What we're looking for is the speed of the two trucks. So that's going to be our unknown quantities. So we'll let X be the speed or the rate of the fast truck, and we'll let Y be the rate or the speed of the slower truck. We can see that after 7 hours, we have some information about how far the trucks have traveled. So we're going to let time be 7 hours. And we can see from the third sentence that the slower truck has traveled 301 miles. So we know that the distance for the slow truck is 301 miles. And after 7 hours, the faster truck is 56 miles ahead of the slower truck. So the distance the fast truck has gone is 301 plus 56. Now, by setting up the information in this table, we have everything organized, and we can use the fact that distance is equal to rate times time to come up with our two equations. So for the fast truck, the total distance was 357 miles. So we can say 357 is equal to the rate, which is the unknown, x, times the time, x times 7 or 7x. And then for the slower truck, distance equals rate times time is going to be 301 is equal to y times 7 or 7 times y. Now we can solve each of these equations. Let's start with 357 equals 7x, divide by 7 from both sides, and we can see that x is equal to 51. And then take the second equation, 301 is equal to 7y, divide by 7, and we can see that y is equal to 43. Now, for word problems, you should always write your answer in terms of the words that make this solution meaningful to the problem. So if x is equal to 51, that was the rate of the fast car, or the fast truck. So we can say that the fast truck is traveling at 51 miles per hour, when the slow truck is traveling at 43 miles per hour. And you can double check your solution by looking at the original sentences. After 7 hours, the faster truck is 56 miles ahead of the slower truck. If you were to replace the x of 51 miles per hour into the distance equals rate times time, so that x is equal to 51, and 51 times 7 does give you 301 plus 56. And y is equal to 43, and we can say 7 times 43 does equal 301. So we know that this is the solution to that word problem. Given the cost function c of x and the revenue function r of x, find the number of units x that must be sold to break even. So we have a c of x, that's our cost function. Now the cost function has fixed costs, in this case the $1,100. Even if you don't produce any units, if x is 0, the cost is still going to be $1,100. And then the revenue equation is 105x. So for this particular example, you can consider that it costs about $95 per unit plus the fixed cost of $1,100, where the units are selling for $105 a piece. So in order to break even, we've got to determine x, the number of units, so that the cost is equal to the revenue. So the break even, we can say that cost equals revenue. So we're going to take our cost equation, which is 95x plus 1,100 equals 105x, our revenue. Now when we solve this equation for x, we can determine that break-even number. We can do this by subtracting 95x from both sides, and we get 1100 is equal to 10x, and then by dividing both sides by 10, we get that x is equal to 110. That's 110 units that must be sold in order to break even. And you can check this by finding the cost of producing 110 units, plugging that back into the original equation is $95 per unit, so it's 95 times 110, plus the fixed cost of $1,100. So the cost of producing those 110 units is going to be $11,550. And let's look at the revenue. The revenue found by selling 110 units is found by multiplying 105 times 95. And you see that it's $11,550 as well. So when you produce 110 units, the total cost is $11,550 and the total revenue is $11,550. So 110 units is our solution. That's our break-even point. Let's look at the second example. The cost of producing X items for the second example is 0.3x plus 1400. That 1400 is considered the fixed cost. That's going to be included no matter how many units are produced. So our cost is 0.3x times $1,400. And the revenue is 1.3x. So each item X sold is sold for, say, $1.30, and then the variable cost is the 0.3. So we want, again, to find that break-even point. That's where the cost is equal to the revenue. So we're going to write the equation as the cost of 0.3x plus 1400 must equal the revenue of 1.3x. We can solve this equation by subtracting 0.3x from both sides of the equation. And then we get 1400 is equal to x. So x equals 1400. That's our number of units that must be sold to break even. And we can check the cost of producing 1,400 units and the revenue for selling 1,400 units and confirm that our cost will equal our revenue. So our check step, we want to find the cost of 1,400 units, and by plugging that in, you get 0.3 times 1,400 plus 1,400. You get 1,820, and then the revenue for selling 1,400 units would be $1,820. So in business, you want to make a profit. You don't want to just break even. So in order to make a profit, then you could say you would have to sell more than 1,400 units to make a profit. A gift box manufacturing company recently purchased $1,000 worth of new equipment to make gift boxes to sell. The cost of producing a package of gift boxes is 50 cents, and it is sold for $3. Find the number of packages that must be sold for the company to break even. In this problem, we want to come up with a cost equation and a revenue equation. Now the cost equation, we can use C of x as our cost function. Cost includes the fixed costs and the variable costs. It's going to cost 50 cents or 0.5 for each unit x, and the price of the fixed cost, the new equipment, of $1,000. So our cost is 50 cents for each unit or 0.5x plus the $1,000 for the equipment. The revenue equation, R of x, is going to be since we know that the boxes are sold for $3, it's going to be 3 times X, 3 times each unit. In order to break even, our cost must equal the revenues. So C of X needs to be equal to R of X. So the cost equation is 0.5X plus $1,000. So that's 50 cents for each unit plus $1,000 fixed cost is equal to the revenue of $3 per set, which is 3X. Now we can solve this equation by solving for X, subtract 0.5X from both sides of the equation, and we get 1,000 is equal to 2.5X, and then by dividing both sides by 2.5, we find that X is equal to 400. So 400 units must be sold, or 400 packages of gift boxes must be sold in order for the company to break even. And we can check by looking at the cost of producing 400 units. It's 50 cents, or 0.5 times 400 plus the $1,000 fixed cost. And that is going to equal $1,200. The revenue by selling 400 boxes is $3 for each unit. So that's 3 times 400, which is also $1,200. So we see that if selling 400 units, the company breaks even. So in order to make a profit, we would want to sell more than 400 units.